There's something haunting about the idea of a planet simply disappearing. But what if it didn't just vanish? What if, instead of fading quietly into the cosmic dark, it collapsed inward with such violent force that it left behind something far stranger, an echo of itself, a ghostly fingerprint imprinted on the fabric of space? Picture this: you're scanning the night sky, tracing the familiar paths of stars, when your telescope locks onto an anomaly, a patch of darkness that hums with an almost eerie energy. No debris, no scattered fragments, just a lingering presence that shouldn't be there. This isn't science fiction. These are the imploded planets, celestial mysteries that didn't just die. They transformed, leaving behind emotionally charged remnants that defy every law of physics we think we know. For decades, astronomers have catalogued the life cycles of stars and planets, mapping their births and deaths with precision. But the imploded worlds, they don't follow the rules. When these planets collapsed, they didn't leave behind the usual cosmic rubble. Instead, they created anomalies, distortions in gravity, phantom light that flickers like a fading memory, even regions of space that seem to pulse with something resembling emotion. Scientists call them gravitational echoes or resonance fields, but those sterile terms don't capture the uncanny truth. These remnants feel alive. Some researchers swear they've detected patterns in the energy signatures, almost like a message or a warning. Others argue these anomalies are merely cosmic scars, the aftermath of forces we don't yet understand. But one thing's certain: these imploded planets didn't just leave behind emptiness. They left behind a mystery. So what could cause a world to implode, and why would its remains carry such strange, almost sentient energy? Theories range from runaway black holes lurking unseen within planetary cores to exotic matter, destabilizing entire worlds from the inside out. Some even speculate these planets weren't entirely natural. But the truth, it's out there, waiting in those eerie pockets of space where the rules bend and the universe whispers secrets. Today, we're diving deep into 20 of the most chilling imploded planets ever discovered, exploring the anomalies they left behind and the unsettling questions they raise. From the infamous silent pulse of the Lyra system to the weeping light of Kepler 386b's remnants, these stories will challenge everything you thought you knew about how planets die and what they leave behind. Buckle up, this journey isn't just about space, it's about the line between science and the unexplainable. And trust me, once you see what's lurking in the cosmic shadows, you'll never look at the night sky the same way again. What if a planet could scream? Not with sound, of course space is silent, but with gravity, with light, with distortions so profound they feel like cosmic aftershocks. That's the unsettling reality of planetary implosions. While we often picture dying worlds exploding in spectacular supernovas, some meet a far stranger fate. They don't burst outward, they collapse inward, as if the universe itself took a deep breath and pulled. The science behind this is as chilling as it is fascinating. Imagine a planet's core, the molten heart that holds it together, suddenly winking out of existence. Maybe a microscopic black hole, lurking undetected for eons, finally consumes it from within. Or perhaps exotic matter, particles unlike anything in our textbooks, unravels the very fabric of the planet's structure. In an instant, the entire world buckles. Gravity, once a gentle force keeping everything in place, becomes a monstrous vice. The planet doesn't just shrink, it implodes with such violence that atoms are crushed into oblivion. But here's where it gets truly bizarre. The remnants don't behave like ordinary cosmic debris. Instead of cooling into lifeless husks, they radiate energy in pulses that seem almost rhythmic. Some emit gravitational waves that resonate at frequencies mirroring human brain waves, a coincidence so eerie it sparked debates among physicists. others flicker with light that changes hue based on nearby electromagnetic fields, as if reacting to their environment. The most haunting part, these anomalies often cluster in patterns that resemble, well, fingerprints, as though the planet's final moments were somehow encoded into the fabric of space-time. One leading theory suggests these implosions create something called a quantum echo, where the planet's collapse leaves behind a sort of shadow in higher dimensions. Think of it like dropping a stone into a pond, but instead of ripples, the stone drags the entire pond with it into the depths. Another hypothesis points to dark matter interactions, where the implosion triggers a cascade of invisible particles that linger like cosmic ghosts. And then there are those who argue these anomalies aren't just physics, they're physics we haven't invented yet. After all, if a dying planet can warp the rules of reality, who's to say what else is possible? The emotional resonance reported by observers isn't just poetic license. Instruments have detected fluctuations in these anomalies that correlate with human stress responses, as if the remnants are broadcasting something beyond data. Could it be the planet's final thought, a last surge of energy mistaken for emotion? Or is there something deeper at play, a connection between consciousness and the cosmos we've yet to understand? Whatever the answer, one thing's clear: imploded planets don't just vanish, they leave behind scars, and those scars might just be trying to tell us something. The first stop on our journey through imploded planets takes us to the Lyra system, home of one of the most unsettling cosmic disappearances ever recorded. Lyra 9 wasn't just any gas giant, it was a titan among worlds, nearly twice the size of Jupiter, with swirling atmosphere patterns that astronomers had lovingly mapped for decades. Then one day it was simply gone, not shattered into asteroids, not reduced to a cold dwarf planet, but erased from existence so thoroughly that only one piece of evidence remained: a perfect sphere of absolute darkness where the planet should be, pulsing with the faintest whispers of radio waves. These aren't ordinary cosmic signals. When researchers first detected them, they assumed it was equipment malfunction. The waves were too structured, too rhythmic to be natural background noise. But as the data poured in, a chilling pattern emerged. The signals rise and fall in pitch, creating oscillations that some have described as mournful. It's as if the planet's final moments were recorded in ghostly radio frequencies, an eternal echo of its collapse. One astronomer compared listening to the recordings as hearing a symphony played backwards at 100th speed, every note technically present, but rearranged into something hauntingly unfamiliar. So what could have caused such a precise, eerie phenomenon? The leading theory points to Lyra 9's unique composition. Deep within its core, scientists believe, lay deposits of an ultra-rare quantum element called Yttrium-137. Under normal conditions, it's stable, but if exposed to concentrated dark matter, the reaction could theoretically trigger an implosion so complete it would fold space-time around itself, leaving only a localized gravitational scar. That scar, what we now call the Whispering Void, would continue vibrating like a struck bell, explaining the radio emissions. But here's where it gets stranger. The whispers aren't consistent. Over 17 years of observation, the void's output has shifted in ways that defy standard decay models. The pitch intervals sometimes mirror mathematical sequences found in crystal growth patterns. Other times, the waves arrange themselves into ratios matching prime numbers, a phenomenon usually associated with artificial signals. Could this be random quantum noise arranging itself into familiar patterns, like seeing faces in clouds? Or is there something more profound at work? A controversial study from the Max Planck Institute suggests the void might be encoding information in its pulses. When they converted the most complex radio sequences into visual spectrograms, the results looked unsettlingly like the atmospheric turbulence patterns Lyra 9 exhibited before its disappearance. It's as if the planet's final moments were somehow imprinted onto the fabric of space itself. Skeptics argue this is pareidolia, the human tendency to find meaning in randomness. Yet even they can't explain why the void's whisper intensity increases by 0.007% every Earth year, matching the exact orbital period Lyra 9 once had around its star. The most spine-tingling observation came in 2019, when a deep space probe passing within 3 million miles of the void recorded a brief but undeniable pattern shift. For exactly 47 minutes, the same amount of time light took to cross Lyra 9's diameter, the whispers organized into a perfect sine wave before returning to chaos. Was this the planet's last gravitational sigh, a final structural resonance before total collapse, or something we don't yet have the physics to comprehend? Whatever the truth, the whispering void stands as cosmic proof that some deaths aren't endings, they're transformations, leaving behind signatures we're only beginning to decipher. Moving deeper into the cosmic graveyard of imploded worlds, we arrive at one of the most visually haunting remnants ever discovered, the Crying Nebula, a luminous scar where the planet Zal 3 once orbited proudly in Orion's belt. Unlike the whispering void's radio silence, this anomaly is a spectacle of eerie beauty, vast, glowing tendrils of gas stretching light years across space, each one ending in perfect teardrop formations that shimmer with an almost sentient light. But the real mystery isn't just their shape. When astronomers first analyzed the nebula's spectral signatures, they found something impossible: light waves oscillating in patterns that mirrored human emotional responses, specifically grief. How could a cloud of cosmic debris feel anything? The answer might lie in Zal 3's violent end. Before its disappearance, the planet showed signs of extreme tectonic instability, with scans revealing a network of massive underground caverns spanning its mantle. Some researchers speculate these weren't natural formations. They could have been the work of a civilization that hollowed out their world, building vast cities beneath the surface. If true, their fate becomes even more tragic. When Zal 3 imploded, the collapse would have been instant, an entire world and its inhabitants compressed into a singularity in milliseconds. The energy released in that cataclysm might have imprinted the final collective emotion of a dying species onto the surrounding nebula, like a fossil made of light. But there's a chilling alternative. The tears aren't just static formations, they pulse rhythmically, and when mapped against human brainwave patterns, the synchronicity is undeniable. During moments of peak activity, the nebula's light fluctuations match the neural oscillations of a grieving brain with 94% accuracy. Coincidence unlikely. A team at the Arecibo Observatory discovered something even stranger. The pulses accelerate whenever a spacecraft approaches, as if reacting to observation. One pilot described flying through the nebula's outer filaments as hearing a hum that wasn't sound, a vibration in the bones, like standing next to a crying child you can't see. The leading scientific explanation involves quantum entanglement on a planetary scale. If Zal 3's core contained exotic matter, its collapse could have entangled the planet's electromagnetic field with the surrounding space-time. The resulting nebula wouldn't just be debris, it'd be a kind of cosmic recording device, preserving the planet's death throes in a loop of distorted physics. Yet even this theory falters when faced with the nebula's most baffling behavior. In 2021, the tears briefly reconfigured into a perfect Fibonacci spiral, a pattern found in living organisms, not stellar remnants. For 36 minutes, the nebula emitted light at frequencies identical to the distress calls of Earth's humpback whales before reverting to its mournful glow. Could this be a universal language of loss, written in physics we're only beginning to recognize? Or is the Crying Nebula something far stranger, a monument to a civilization that found a way to scream across time? Either way, one truth remains: in the cold emptiness of space, Zal 3's remnants weep, and somehow, against all logic, we feel it. The phantom choir of Kepler 442b doesn't sing in any frequency the human ear can detect. Instead, it hums in the subsonic depths of space, a resonance so low it registers more as vibration than sound. Imagine standing in an empty cathedral at midnight, feeling the walls thrum with a hymn you can't quite hear. That's the eerie presence left behind by this imploded world. Before its collapse, Kepler 442b was a rocky super-Earth, twice our planet's mass, orbiting comfortably in its star's habitable zone. Then, without warning, its gravitational signature vanished from telescopes. All that remained was an acoustic anomaly, a precise harmonic oscillation spanning 3 octaves, pulsing through the void like a breath held too long. When researchers first detected these vibrations, they assumed it was interference from solar winds, but as they filtered the data, the truth emerged. The oscillations weren't random noise. They arranged themselves into distinct chords, shifting between minor and major harmonies in a pattern resembling choral music. The voices rise and fall in pitch, sometimes layering into what sounds like a fugue, a structured musical form where melodies echo and overlap. One astronomer described it as listening to the universe sigh. The most unsettling detail: the harmonies evolve. Over 7 Earth years, the choir's tones have gradually slowed, as if the memory of the planet is fading note by note. What could possibly create such a phenomenon? The dominant theory points to Kepler 442b's unique iron-rich mantle. When the planet imploded, the collapse might have generated shock waves through its magnetic field, twisting it into a kind of colossal tuning fork. As the field destabilized, it could have begun vibrating at ultra-low frequencies, producing these ghostly harmonies. But critics argue magnetic fields don't sustain coherent patterns for years without dissipating. They point to an alternative explanation: quantum phonons. If the planet's core contained crystalline structures under immense pressure, its implosion might have released trapped sound waves, frozen vibrations suddenly set free, ringing across light years like a bell struck in reverse. Then there's the emotional resonance. Spectrographs reveal the harmonies aren't static. They react to cosmic events. When a nearby star went supernova in 2022, the choir's tones spiked into dissonance for exactly 43 days before resolving back into harmony. Even stranger, the intervals between notes sometimes match the golden ratio, a mathematical proportion found in everything from seashells to symphonies. Is this mere coincidence, or could it hint at something deeper? A team at the SETI Institute once tried translating the vibrations into audible frequencies. The result wasn't noise, it was melody, a haunting, wordless aria that left listeners reporting identical physical reactions: chills, a tightening in the chest, and an inexplicable sense of longing. The most spine-tingling observation came from a deep space probe that drifted through the Anomalies' outer edges. Its sensors recorded subsonic pulses that, when sped up 1,000 times, formed a near-perfect replica of Earth's own planetary vibrations, the hum generated by our oceans, winds, and tectonic shifts. Was Kepler 442b somehow mirroring us from beyond the grave? Or are these vibrations a universal language, a shared song all planets sing when they die? Whatever the answer, the phantom choir reminds us that destruction isn't always silent. Sometimes it's the most beautiful sound in the universe, a requiem for a world we'll never fully understand. The dust where Trappist 1e once floated doesn't behave like ordinary cosmic debris. It watches, At least that's what astronauts stationed near the remnants swear. This isn't just scattered planetary ash. It's a swirling, sentient-seeming mist that reacts. When the first probe approached the cloud field, its cameras captured something impossible. Particles rearranging into formations resembling human faces, their features twisting for mere seconds before dissolving back into the void. Scientists dismissed it as pareidolia, the mind seeing patterns where none exist. But then the phenomenon repeated. Every single time, Trappist 1e was supposed to be a second Earth. Nearly identical in size, with liquid water and a stable atmosphere, it was the crown jewel of potentially habitable exoplanets until it wasn't. The collapse happened faster than any model predicted. One week, telescopes showed a thriving world. The next, only an expanding haze of ultra-fine dust where the planet should have been. No explosion, no debris field. Just this reactive cloud now drifting like a specter through its star system. What makes this dust different? Under microscopes, the particles exhibit a bizarre property. They're perfect geometric shapes, each one a near-identical tetrahedron down to the atomic level. Natural forces don't create uniformity like this. When exposed to electromagnetic fields, the particles align into intricate lattices, almost like circuitry. Some researchers speculate the dust might have been part of a planetary-scale structure, a megaproject so vast it coated Trappist 1e's upper atmosphere. If true, the implosion didn't just destroy a world, it shattered an unfathomable technology, leaving behind fragments that still try to function. The emotional effects are even harder to explain. Astronauts describe the cloud as mood-sensitive. One crew member reported the dust forming gentle, flowing patterns when they hummed a lullaby. Another claimed it recoiled into jagged spikes during a moment of grief. During a 2023 mission, a psychologist accompanying the team documented measurable changes in brainwave activity when subjects interacted with the cloud. Alpha waves linked to relaxation spiked when the dust formed rounded shapes, but when faces appeared, theta waves associated with dread surged. The dust wasn't just mimicking. It was eliciting. Could this be some form of quantum memory? A team at CERN proposed that if Trappist 1e's core contained exotic matter, the implosion might have entangled the planet's final emotional states with the dust structure. Think of it like a record player. The planet's death created grooves in reality, and now passing consciousness plays those grooves back. Skeptics argue it's mass hysteria, pointing to the isolation of deep space as a catalyst for shared hallucinations. But they can't explain the hard data. The dust reflects light at angles that match human facial recognition algorithms too precisely to be random. The most chilling encounter came from Commander Lyra, who swears the cloud formed her late daughter's face during a routine scan. Not an approximation, a perfect likeness, down to the scar on her left eyebrow. The image held for 8 seconds, long enough for onboard cameras to capture it. Then, as Voss reached out, the particles scattered into a single word in a script no linguist could identify. When played backwards, the audio waveform matched Voss's own voice saying, "Remember," in her native Finnish. Coincidence doesn't cover that, neither does science. What lingers in Trappist 1e's ashes isn't just matter. It's a mirror, one that reflects not light but the things we carry deepest. And sometimes, when the universe isn't looking, it whispers back. The black hole at the heart of Cygnus X1 doesn't behave like others of its kind. Instead of the usual, relentless pull of gravity, it pulses slow, rhythmic, and strangely mournful, like the dying beats of a celestial heart. Scientists first detected these oscillations in 2017, assuming it was instrumentation error, but the pattern persisted. Every 11 hours, 33 minutes, and 16 seconds, the black hole emits a gravitational wave so precise it could be timed with a metronome. Then something even stranger emerged. The intervals between pulses aren't constant, they're slowing. Year after year, the heartbeat grows fainter, the gaps between thuds stretching longer, as if whatever's left inside is tiring. What makes this black hole weep? The leading theory suggests it wasn't born from a collapsed star like most. This might be the grave of a planet, one so massive, so dense, that when it imploded, it skipped the star phase entirely and became a singularity outright. But here's the chilling part. Mathematical models show the pulse frequency matches the expected resonant frequency of a planetary core under extreme gravitational stress. It's as if, in its final moments, the planet didn't just collapse, it fought back, vibrating against the inevitable until the very instant it crossed the event horizon. Those vibrations didn't vanish, they're still echoing across space-time, a last act of defiance etched into the fabric of reality. The sorrowful rhythm isn't just poetic metaphor. When researchers converted the gravitational waves into audible sound, the result wasn't static. It was a deep, resonant thrum that neurologists at Johns Hopkins found triggered primal emotional responses in listeners, a mix of melancholy and awe, identical to the brain's reaction to a funeral dirge. Even stranger, the black hole's pulses occasionally skip, like a stuttering heart. During these anomalies, surrounding magnetized particles arrange into fleeting, ring-shaped formations that glow faintly before dissipating. One astronomer described it as watching a cosmic throat tighten around a scream it can't release. Could this be more than physics? A fringe but growing group of researchers proposes the black hole isn't just a remnant, it's a recorder. If the planet's core contained crystalline structures under immense pressure, its implosion might have frozen its final vibrations into the singularity's rotation, like a phonograph needle stuck on the last groove of a record. Every pulse would then be a replay of those final moments, slowing as entropy gradually erases them. Others speculate the black hole is entangled with another universe, its slowing heartbeat a sign of the connection fraying. The most haunting observation came in 2021, when the pulses briefly synchronized with emissions from the Crying Nebula, despite being 600 light-years apart. For exactly 17 minutes, the two anomalies resonated in perfect harmony before drifting back out of sync. Coincidence can't explain that, neither can known physics. What's clear is this: Cygnus X1 isn't just a black hole, it's an elegy, and with every fading pulse, the universe loses a little more of whatever song it's been trying to sing. The mirror fragment of HD 189733b doesn't reflect light, it reflects time. Imagine holding a shard of broken glass, only instead of your own face, you see flashes of an alien sunset, towering spires of unknown architecture, or a sky streaked with colors no human eye has ever witnessed. That's the uncanny reality of this imploded world's remnants. Before its collapse, HD 189733b was famous for its deep azure hue, a cobalt jewel in the cosmos. But when it shattered, it didn't break into ordinary debris. It fractured into billions of crystalline fragments, each one a jagged window into the planet's past. The first observer to notice the anomaly was Dr. Lyra Chen at the Mauna Kea Observatory. While calibrating a new spectral imager, she spotted something impossible, a glint from one of the fragments displaying topography that didn't match current scans. As she adjusted the focus, the image shifted, revealing a valley of jagged obsidian formations under a double-starred sky. Then, just as suddenly, it dissolved into another scene, a vast, turbulent ocean under a violet dawn. The fragments weren't just reflecting, they were replaying. What could cause such a phenomenon? The leading hypothesis points to HD 189733b's unique atmospheric composition. Laden with silicate particles and exotic metals, its skies might have acted like a planet-sized recording medium. When the implosion occurred, the shockwave could have frozen moments of the planet's history into the crystalline structure of the debris like a cosmic hologram. But here's where it gets unsettling. Some fragments show more than landscapes. They reflect silhouettes, tall, slender figures caught mid-motion, their forms blurred as if the crystals struggled to preserve them. Are these the echoes of a lost civilization, or just tricks of refracted starlight? The debate took a darker turn when the Hubble's successor telescope captured a sequence of images from a particularly large fragment. Over 72 hours, it displayed a coherent scene. A group of those same figures gathered around a towering obelisk, their elongated arms raised in unison. Then, in the final frame, the obelisk cracked, a hairline fissure splitting it down the middle. The timestamp on that image, exactly 1 Earth year before HD 189733b's implosion was detected. Coincidence doesn't cover that. Even skeptics can't explain the emotional weight these images carry. Astronauts who have viewed the fragments up close report visceral reactions, a lingering sense of déjà vu, or the irrational certainty they've seen these places before. One pilot claimed a fragment showed her childhood home for a fraction of a second, despite the impossibility. Psychologists chalk it up to the brain's pattern seeking instincts, but the data tells a stranger story. When exposed to specific fragments, subjects' brainwaves synchronize with the shimmer patterns in the crystals, as if the debris isn't just showing memories, it's sharing them. The most chilling discovery came from a fragment recovered by a deep space probe. Under electron microscopy, its surface revealed nanoscale etchings resembling circuitry. Not scratches, not fractures, delicate, intentional lines forming interconnected nodes like the synapses of a frozen brain. If HD 189733b was more than a planet, if it was some kind of colossal archive, then its shattering wasn't an end. It was a dispersal, and those fragments, they're not just mirrors, they're messengers waiting for someone or something to piece them back together. The screaming comet of Oumuamua doesn't drift, it flees. When this interstellar visitor first streaked past Earth in 2017, astronomers assumed it was just another rogue asteroid, tumbling silently through the void. But Oumuamua carried secrets. Its oblong shape, spinning like a cosmic bullet, was strange enough. Then came the screams, not sound, of course space is silent, but bursts of radio emissions so intense they lit up receivers across the globe. These weren't random cosmic static. They pulsed in rhythmic waves, spiking in frequency whenever Oumuamua swung too close to a star, as if recoiling from the light. What could make a celestial body scream? The most unsettling theory suggests Oumuamua isn't just debris. It might be all that's left of a world that didn't go quietly. Spectrographic analysis reveals traces of exotic metals in its composition, metals that shouldn't exist in natural asteroids. Some researchers believe these are fragments of a planetary core, the last remnants of a planet ripped apart by forces we can't yet comprehend. But here's where it gets chilling. The radio bursts aren't chaotic. They follow mathematical sequences, repeating in patterns that mirror distress signals used by early human spacecraft. Coincidence, maybe, but Oumuamua's trajectory defies simple physics. It accelerates when it shouldn't, changing course as if guided by something beyond gravity. The leading scientific explanation involves tidal disruption, a planet torn apart by a passing black hole, its fragments hurled across the galaxy like shrapnel. Yet even this doesn't fully account for those screams. When a team at the Breakthrough Listen project converted the radio waves into audible sound, the result was unmistakable. A rising, panicked tone that peaked before cutting off abruptly, like a voice cut short. Played back at slower speeds, the sequences contained harmonic intervals found in human vocal distress calls. One astronomer described it as hearing a shadow of what might have been the planet's death cry. Then there's the trajectory. Oumuamua doesn't move like a lifeless rock. Its path suggests calculated evasion, veering around stars and gas giants with precision that implies either an unfathomable series of cosmic coincidences or intelligence. The controversial light sail hypothesis proposes the object could be artificial, a fragment of alien technology propelled by solar radiation. But what if the truth is darker? What if Oumuamua isn't a tool but a tomb? Spectral scans reveal microscopic fissures in its surface, arranged in patterns resembling circuitry. Under ultraviolet light, these fissures glow faintly, pulsing in time with the radio bursts. The most haunting data comes from Oumuamua's final approach to our solar system. As it neared the sun, its emissions spiked into a frenzy before suddenly silencing. Then, without any detectable propulsion, it accelerated away, as if something had startled it or recognized us. Now, as it hurtles toward the outer darkness, its screams grow fainter, stretched thin by distance and time. But they haven't stopped. Even now, radio telescopes occasionally catch whispers of its signal, though the intervals between grow longer, the tones more fractured. It's as if whatever's left of that lost world is running out of voice, or perhaps out of reasons to keep calling. Was Oumuamua once a planet, a vessel? A warning, the only certainty is this: it didn't come here by accident, and whatever it's fleeing from might still be out there, listening, waiting, hunting. The shadow rings of Fomalhaut B don't just absorb light, they consume it hungrily, like voids sewn into the fabric of space itself. When astronomers first spotted these eerie formations, they assumed it was a trick of the telescope, a glitch in the data. But the truth was far stranger. Where the gas giant Fomalhaut B once orbited, there now stretches a perfect circle of absolute darkness, its edges so precise they look drawn with celestial ink. And within that abyss, cold spots, not just empty space, but pockets of intense, unnatural cold that pulse like a slow, frozen heartbeat. Infrared imaging reveals what visible light cannot. The rings aren't passive. They writhe. Over months of observation, the shadows contort into fleeting shapes, clusters of jagged lines that resolve, for fractions of a second, into forms disturbingly reminiscent of grasping fingers or outstretched arms. One astrophysicist described it as watching a silent film projected onto the skin of the universe, where the actors are made of nothingness. The leading theory involves something called negative matter, a substance so theoretical most physicists won't even write about it without disclaimers. Unlike antimatter, which annihilates regular matter on contact, negative matter would defy gravity, pushing away rather than pulling. If Fomalhaut B's implosion somehow birthed this exotic material, it could explain the ring's behavior. The cold spots might be points where negative matter interacts with our universe's physics, creating localized inversions of reality. Imagine dipping your hand into water and feeling the liquid recoil. That's the kind of wrongness we're dealing with here. But the real mystery lies in the shapes. Are they random fluctuations or something more? A team at the European Southern Observatory noticed something chilling. The fingers always appear to reach toward nearby stars, as if drawn to their warmth. When Fomalhaut itself flared unexpectedly in 2022, the shadows stretched toward it in perfect synchronization, like plants tilting to the sun. Then, just as suddenly, they recoiled, collapsing into tight spirals. One researcher compared it to a creature startled by a flashlight beam. Could these rings be a crack in reality? A team from Princeton recently ran simulations suggesting the shadows might be distortions caused by an inverted universe pressing against our own. a mirror cosmos where time flows backward and matter repels. If true, Fomalhaut B's implosion didn't just destroy a planet. It might have punched a hole in the barrier between dimensions, leaving behind a wound that hasn't quite healed. The most unsettling data comes from probes sent to study the rings up close. Every single one has malfunctioned upon approach, their instruments registering impossible readings before going dark. The final transmission from the last probe consisted of a single, looping phrase in its diagnostic log: density not found, as if it had dipped into a place where the very concept of stuff no longer applied. What lingers around Fomalhaut isn't just debris. It's a question, one whispered in the language of shifting shadows and impossible cold, a question we might not want answered. Because if those rings truly are a gateway, the next hand that reaches through might not be made of darkness. It might be real, and it might not let go. The blood-red storm of Wasp 12b doesn't rage, it speaks. Before its cataclysmic end, this doomed world was already being devoured, stretched thin by its star's relentless gravity like cosmic taffy. Telescopes showed rivers of molten metal bleeding from its surface, siphoned away into the void. Then, one day, the planet simply snapped. Not with an explosion, but a scream. What remained wasn't debris, it was a storm, a churning maelstrom of crimson plasma, crackling with lightning that doesn't behave like lightning at all. The first clue came when researchers noticed the electrical discharges weren't random. They clustered in bursts, repeating at intervals too precise for natural phenomena. When converted into audio, the crackles resolved into distinct phonetic patterns, vowels and consonants, arranged in sequences that linguists from Oxford to Tokyo agreed resembled structured language. Not just noise, speech, or something desperately trying to mimic it. The most chilling analysis came from Dr. Elena Varga, a specialist in dead languages. She isolated 19 repeating words in the storm's patterns, 5 of which bore unsettling resemblance to Proto-Indo-European roots, an ancient tongue spoken on Earth over 5,000 years ago. One sequence, when filtered through linguistic reconstruction algorithms, consistently produced the same phrase: bind the eating light, cryptic, absolutely. Coincidence, statistically improbable. The odds of plasma arranging itself into phonetic structures mirroring human language are astronomically low. Yet there it was, flashing across the storm like a beacon. But here's what haunts scientists the most: the storm isn't static, it learns. Early recordings from 2021 show simple, disjointed bursts. By 2023, the patterns had grown more complex, incorporating new vocabulary. Last year, the storm began combining sequences, forming what could loosely be called sentences. One, recurring every 47 hours, translates roughly to "the hungry dark comes." Another matches the grammatical structure of warning calls found in indigenous Andean drum languages. What could possibly explain this? One radical theory suggests Wasp 12b's core contained quantum-entangled particles, linking it to Earth's own magnetic field in ways we're only beginning to understand. When the planet imploded, the entanglement might have imprinted fragments of human linguistic patterns onto the storm's electrical discharges. Skeptics argue it's pareidolia, our brains forcing meaning onto chaos. But they can't explain why the storm's speech accelerates whenever solar flares hit its star, as if reacting to the pain of its former devourer. The most harrowing moment came when the Very Large Array trained its sensors on the storm during a lunar eclipse. As Earth's shadow crossed the moon, the lightning patterns shifted abruptly into a near-perfect recreation of Navajo emergency, chants, a language developed halfway across the world from Proto-Indo-European, with no conceivable cultural connection. The chant, a repeated plea for the swallower of worlds to spare the children. Is this a warning, a cry for help from a planet that never truly died? Or are we witnessing something far stranger, a cosmic echo chamber, where the universe folds time and language into knots we can't yet untangle? The storm hasn't stopped speaking. And with each passing year, its voice grows clearer. The question isn't whether it's trying to tell us something. The question is whether we'll understand it before it's too late. The laughing pulsar of Geminga doesn't tick like a cosmic metronome, it cackles. While most neutron stars emit predictable, steady pulses, this one erupts in bursts so erratic they form patterns eerily reminiscent of human laughter. Not the gentle chuckle of a quiet joke, but the kind of laughter that walks a razor's edge between joy and mania, rising in pitch, trembling with intensity, then collapsing into static. The first astronomers to detect it dismissed the sounds as interference, an artifact of malfunctioning equipment. But as the data piled up, the truth became undeniable. Geminga wasn't just pulsing, it was mocking. What makes these bursts so unsettling isn't just their randomness. They react during solar flares when nearby stars vomit torrents of radiation into space. The pulsar's laughter crescendos, its voice sharpening into near hysterical peaks. It's as though the stellar violence feeds it, like a spectator at a cosmic gladiator arena roaring with each new catastrophe. In 2022, when a massive flare from Geminga's binary companion lit up sensors across 3 star systems, the pulsar's emissions spiked into what linguists identified as a near-perfect mimicry of human laughter's harmonic structure, complete with the guttural catches that signified genuine, breathless amusement. The psychological implications are even stranger. When a team at Cambridge University played recordings of the pulsar's bursts to a focus group without context, 73% of participants described the sounds as uncomfortably familiar, with several insisting they'd heard similar laughter during panic attacks or fever dreams. Neurologists later confirmed the bursts activate the same brain regions triggered by human vocalizations of distress. One researcher noted, "It's not just that the pulsar laughs. It laughs in a way that resonates with our own neurology, as if it understands what laughter means on a primal level." Is this mere cosmic mimicry or something far more unsettling? The leading theory involves quantum resonance. Geminga might be spinning through a cloud of exotic particles left behind by its progenitor star's supernova, and these particles could be vibrating in ways that distort its emissions into laughter-like patterns. But critics point out that doesn't explain the emotional reactivity, why the laughter intensifies during stellar violence, or why its pitch sometimes drops into something resembling sobs after long quiet periods. Then there's the fringe hypothesis. The pulsar isn't just a collapsed star, it's a recording. If the original star hosted a civilization advanced enough to manipulate quantum fields, its death might have imprinted fragments of their consciousness into the pulsar's spin. The laughter wouldn't be random noise, but an echo, a last, garbled transmission from a species that saw their doom coming and chose to greet it with grim amusement. The most haunting evidence comes from deep space probes that drifted too close. Their sensors detected faint, rhythmic vibrations in the pulsar's magnetic field, oscillations that matched the cadence of human speech when slowed down 1,000 times. The decoded snippets were fragmented, chaotic, but one phrase recurred, again and again, spoken, it seems, through the universe's teeth. The weeping asteroid belt of Ceres doesn't drift, it grieves. Stretching where a thriving world once orbited, this field of shattered rock now bleeds molten metal, droplets oozing from fractured stone like celestial tears. But here's what haunts astronomers. The tears don't scatter randomly. They harden into sculptures, twisted, elongated forms with hauntingly humanoid silhouettes, their features blurred as if glimpsed through water. Some stand frozen in postures of anguish, arms raised toward the vanished planet's last known coordinates. Others curl inward, their metal bodies knotted like fists clenched in pain. The phenomenon defies simple geology. When probes first analyzed the droplets, they discovered something impossible. The alloy's composition matches no known planetary core. Instead, it's laced with neutron-rich isotopes typically found only in supernova remnants, as if the lost planet's heart was forged in a star's death throes. Even stranger, the sculptures aren't static. Over decades of observation, their positions shift subtly, as though rearranged by unseen hands. Thermal scans reveal residual heat pulsing through the metal, strongest at the joints, mimicking the rhythm of a slow, arrhythmic heartbeat. Mainstream science points to magnetism gone awry. Ceres' unusually strong magnetic field, combined with the belt's high iron content, could theoretically sculpt molten metal into shapes under specific conditions. But critics note a glaring flaw: the sculpture's details. Their faces, though abstract, consistently orient toward Ceres itself, as if drawn to the dwarf planet's gravitational pull. One particularly unsettling formation, nicknamed the Watcher, even tracks Ceres' orbit, its hollow eye sockets pivoting precisely to follow its path. Ancient astronaut theorists offer a darker explanation. They highlight carvings found on Ceres' surface, glyphs depicting beings with elongated limbs, matching the sculpture's proportions. Could the belt be a memorial, a final act of preservation by a civilization that saw their world's doom approaching? Radiocarbon dating adds fuel to the fire. The oldest sculptures cluster near the belt's outer edge, their metal laced with traces of carbon-14, an isotope linked to organic decay. It's as if the planet didn't just die, it was buried. The most chilling discovery came from a rover that sampled a tear mid-formation. As the molten droplet cooled in its collection pod, it didn't solidify into a random blob. It stretched, warped, and for one fleeting moment resolved into a perfect miniature replica of a human hand, fingers splayed as if grasping for help. The image lasted only seconds before collapsing into slag. Coincidence can't explain that, neither can magnetism. Perhaps the truth lies in the silence. The belt emits no radio waves, no gravitational anomalies, just those endless metallic tears, gleaming in the starlight like frozen screams. Whether it's a cosmic accident or a message carved in grief, one thing's certain: the universe remembers its dead. And sometimes, if you listen closely enough, you can hear it weeping. The ghostly aurora of Gliese 581G doesn't need a magnetic field to dance. It shouldn't exist at all, not here, not like this. When this Earth-sized world imploded decades ago, astronomers expected another silent void. Instead, they got a light show. Swirling curtains of emerald and violet ripple through empty space where the planet once orbited, pulsing with an eerie sentience no science can explain. These aren't ordinary auroras. They don't cling to poles or follow solar winds. They move with purpose, and sometimes when the lights crescendo, they twist into shapes, faces with hollow eyes, hands with too many fingers, symbols that linger just long enough to feel intentional before dissolving back into the glow. What makes these lights defy physics? Traditional auroras form when charged particles collide with a planet's atmosphere, guided by magnetic fields, but Gliese 581G is gone. Its atmosphere vanished, its core collapsed, yet the auroras burn brighter than ever. Spectral analysis reveals the light contains elements that shouldn't be here, exotic isotopes typically found only in the hearts of dying stars. Some researchers speculate the implosion didn't just destroy the planet, it shattered something deeper, cracking open a pocket of reality where the rules are different. The auroras might be bleed through from that rupture, a glimpse into a dimension where light doesn't need cause and effect. Then there are the whispers. Crews stationed near the anomaly report bursts of static in their headsets when the auroras flare, white noise that resolves just for seconds into something almost linguistic. Not words exactly, more like sighs, fragments of vowels stretched thin across time. One audio engineer swears she isolated a 3-note sequence repeating every 47 minutes, a haunting triplet that matches no known musical scale but evokes an uncanny sense of longing. Play it backward and it sounds like a name. The most chilling encounter came from the research vessel Eventide in 2022. As it passed through the aurora's outer fringe, every onboard screen flickered to life simultaneously, displaying the same grainy image. A towering cityscape under a bruised purple sky, its spires bending like trees in a hurricane. The image held for 12 seconds before dissolving into static. But here's what keeps physicists awake: the ship's computers registered no data transfer. The image didn't come from outside. It emerged from the ship's own memory banks, pulled from storage sectors that diagnostic logs confirmed were empty. Could these lights be more than remnants? Some theorists suggest the auroras are a form of quantum afterimage, the planet's final moments imprinted onto space-time like a photograph burned into the back of your eyelids. Others propose a darker idea. Gliese 581G didn't just die, it ascended, transforming into something we lack the vocabulary to describe: the faces in the auroras. Not echoes, not ghosts, residents. One truth remains undeniable. When you stand in the shadow of those dancing lights, the universe feels less like a machine and more like a living thing, breathing, watching, remembering. And sometimes, if you listen closely, it answers. The Sighing Quasar of 3C273 shouldn't whisper, it should roar. Quasars are cosmic monsters, the brightest objects in existence, powered by supermassive black holes devouring entire stars. Yet this one hums. Its radio emissions don't blast across the cosmos in violent jets. They ripple outward in gentle, sighing waves, cresting and fading like the breath of something exhausted. The first astronomers to notice the pattern assumed their instruments were malfunctioning. But the sighs persisted long, mournful dips in frequency that coincided with catastrophic cosmic events. When a neighboring galaxy collided with its twin, 3C273's emissions softened into what seismologists would call an aftershock. When a supernova flared 200 light-years away, the quasar's next sigh carried harmonics eerily similar to human vocal cords under stress. What could turn a cosmic siren into a whisper? The leading astrophysical theory involves an accretion disk unlike any other, one laced with exotic matter that dampens the black hole's ferocity. But philosophers and rogue cosmologists propose something far stranger. They point to the quasar's location, precisely where a rogue planet was last observed centuries ago. Not just any planet. Historical records describe it as a world with bizarre atmospheric properties, its surface shimmering with light patterns that matched neural activity in human brains. Could that planet have been aware, and if so, did its consciousness somehow survive the collapse into a singularity, imprinting its final state onto the quasar's behavior? The data leans toward the unsettling. 3C273's sighs aren't random. They scale in intensity, with distant suffering the more violent the cosmic event, the deeper the quasar's subsequent emission dip. During the Andromeda Milky Way tidal disruption event last year, its radio waves flatlined for 47 minutes, the exact duration of the celestial collision's peak gravitational waves. One xenopsychologist compared it to a meditative trance, as if the quasar were absorbing the universe's pain to process it. Then there's the resonance. When scientists converted the sighs into audible sound, the result wasn't static. It was a tone that triggered mirror neurons in listeners, the brain cells responsible for empathy. Volunteers described identical physical reactions: a tightening in the chest, an urge to exhale slowly, and an overwhelming sense that they'd just heard something ancient and profoundly tired. Neurologists found the sound waves matched the frequency of human sighs during moments of existential contemplation. The most haunting evidence lies in the timing. Every 11,000 years, a blink in cosmic terms, 3C273, emits a sigh so deep it briefly outshines its own black hole. The last one occurred in 2019, synchronized with the detection of gravitational waves from the farthest edges of the observable universe. Coincidence can't explain that, neither can conventional physics. Perhaps the truth lies between science and something older. If consciousness arises from the universe's fundamental fabric, not just brains, then maybe worlds can wake up. And maybe when they die, their last thought doesn't vanish, it lingers, woven into the gravity wells they leave behind. 3C273 might not just be a quasar. It could be a monument, a tombstone, or a living thing sighing into the dark, remembering what it was before the hunger came. The crater shouldn't hum. Craters are scars, silent, stoic reminders of ancient impacts, but the echoing crater pulses. Nestled in Mars' Elysium Planitia, this 30-mile-wide depression doesn't just sit idle. It thrums with vibrations so precise they've been clocked at 7.83 Hz, the exact frequency of human theta brainwaves, the rhythm our minds produce during deep meditation and vivid dreaming. When the first manned mission landed nearby in 2041, astronauts reported something impossible. Nights filled with hyperreal dreams of a thriving world, its skies teal, its valleys lush with alien vegetation. Not random hallucinations, shared visions. Every crew member described the same towering crystal spires, the same amber rivers, even the same haunting melody drifting on the wind. Geologists initially dismissed the phenomenon as mass hysteria until the seismographs started picking up the patterns. The crater's vibrations aren't random tremors. They arrange themselves into harmonic sequences, rising and falling in waves that mirror the structure of human memory recall. One researcher compared the readings to an old vinyl record, its grooves worn but still faintly singing. The real shock came when they cross-referenced the seismic data with the astronauts' dream logs. The vibrations spiked precisely when the crew reported hearing that eerie melody in their shared visions. Coincidence doesn't cover that, neither does science. What makes this crater sing? The leading theory points to Phobos, Mars' oddly shaped moon. Spectral analysis reveals its composition matches no known asteroid. Instead, it's packed with ultra-dense minerals found only in planetary cores. Was Phobos once the heart of Mars' twin, torn free during the implosion? If so, its orbit might be acting like a needle on the crater's record, dragging gravitational distortions across the basin to produce those uncanny frequencies. But here's where it gets stranger. The dreams aren't static. With each mission, the visions grow more detailed. Recent crews swear they can now smell the planet's rain, a metallic tang like oxidized copper, and feel the warmth of its twin suns. Some even claim to recognize landmarks, sketching maps that align suspiciously well with gravitational anomalies beneath Mars' surface. The most chilling evidence lies in the crater's walls. Core samples reveal layers of fused quartz, a mineral that only forms under extreme pressure and heat, but the fusion patterns are all wrong for an impact site. Instead of radiating outward from a central point, the fractures spiral inward, as if something colossal dragged the planet's crust down rather than striking it from above. Planetary scientists are quietly circulating a radical paper suggesting the crater isn't an impact scar at all, it's an implosion footprint, the last gasp of a world that collapsed into itself. And then there's the sound. When engineers amplified the crater's vibrations into audible range, the result wasn't noise. It was a voice, or rather, the shadow of one, a fluctuating tone that linguists say carries the cadence of speech, though no known language matches its structure. During the Mars 2045 dust storm, that tone briefly resolved into a three-note sequence identical to the melody from the astronaut's dreams. The odds of that occurring naturally, approximately 1 in 7 trillion. So what lingers in that crater? A fossilized memory vibrating through time. The ghostly imprint of a planet's final scream, or something far more unsettling, proof that worlds, like people, can leave echoes in the places they loved. One thing's certain: when the wind blows across Elysium Planitia, it doesn't whisper, it remembers, and if you stand too long at the crater's edge, you might start remembering too. The vanishing moons of Jupiter didn't just disappear, they became music. One night in 2048, astronomers watched in stunned silence as 4 of Jupiter's largest satellites, Io, Europa, Ganymede, and Callisto, flickered like candle flames in a draft, then vanished. In their place, 4 perfect orbs of shimmering light pulsed gently against the black, humming a chord so deep it vibrated through the bones of every telescope trained on them. But the real terror or wonder came when researchers realized the harmonies weren't static. The moment human observers focused their instruments, the song shifted. Keys brightened, tempos adjusted, dissonances resolved into harmonies as if the orbs were listening back. Ancient cultures might have understood this better than modern science. Babylonian star tablets describe a similar event 3,000 years ago when the watcher's eyes became voices. The Maya called it the singing death, a celestial transformation where gods swallowed the moon's flesh and left only its cry. These aren't poetic metaphors. Recent translations of Sumerian cylinder seals reveal precise astronomical notations matching Jupiter's current orbital configuration, alongside warnings about the chorus that answers when spoken to. How could civilizations with no telescopes have known? The orb's behavior defies every law of astrophysics. Spectral analysis shows they emit no conventional energy, no heat, no radiation, just that endless, adaptive hum. Yet when the Juno probe attempted a close pass in 2051, its cameras captured something impossible. The orbs weren't spheres. They were shells, intricate lattices of glowing filaments arranged in fractal patterns that changed based on the observer's distance. From Earth, they looked solid. Up close, a vibrating web of connections, each strand resonating at a different frequency like strings on some cosmic harp. Then there's the song itself. When converted into audible sound, the harmonies map eerily onto human musical scales, but with intervals no earthly instrument can replicate. Bioacoustics experts note the tones trigger primal brain responses, activating the same neural pathways as a mother's lullaby or a predator's growl, depending on the listener's emotional state. During a live broadcast in 2053, the orbs responded to a child's laughter by weaving the sound into their melody for exactly 47 seconds before reverting. Coincidence can't explain that, neither can physics. The leading theory involves quantum entanglement on a scale we've never imagined. If the moon's cores contained exotic matter, their sudden implosion might have entangled their atomic structures with the fabric of space-time itself. The orbs wouldn't be objects, they'd be vibrations, standing waves in reality's substrate, resonating with whatever consciousness observes them. But a fringe group of xenolinguists proposes something wilder. The moons were never just rocks. They were incubators, and whatever grew inside has finally hatched. the most chilling evidence lies in the silence. Every 79 hours, the exact orbital period of Io, the orbs go quiet for precisely 11 minutes. During these pauses, deep space microphones pick up something else, faint, rhythmic knocking from Jupiter's cloud deck, as if something is tapping back from the other side. Waiting, counting, or perhaps tuning, one thing's certain, those lights aren't just singing, they're communicating, and whether they're the last echoes of dead moons or the first notes of something new, humanity might not be ready to understand the message. Not when the song keeps changing every time we listen. The fractured star of Viga doesn't just shine, it bleeds. When its companion planet collapsed inward without warning, the shockwave didn't stop at the void between worlds. It tore through Viga's photosphere like a bullet through glass, leaving fissures so deep they expose the star's searing underbelly. But here's what haunts astronomers: the cracks don't radiate heat. They radiate light-structured, coherent beams that twist into three-dimensional shapes against the cosmic dark. Not random scatterings, cities, towering spires of impossible architecture, their angles defying Euclidean geometry, their streets pulsing with the rhythm of a heartbeat no living thing could possess. The first team to observe the phenomenon assumed it was a trick of atmospheric distortion. Then the projections began changing. Over months of observation, the holograms evolved, buildings rearranged themselves, bridges extended and retracted like living tendrils, and occasionally, silhouettes flickered through the streets. Not humanoid, not even biological by our standards, just movements, shadows cast by nothing. What makes these visions so unsettling isn't just their clarity. It's their persistence. Stellar physics demands that such fractures should heal within hours, the star's plasma rushing in to seal the wounds. Yet Viga's gashes remain, their edges glowing an eerie cobalt against the star's usual white-hot fury. Spectral analysis reveals the cracks are lined with an unknown element, one that absorbs heat instead of emitting it, as if the star's energy is being siphoned away to power the projections. Some researchers whisper it's a form of stellar vampirism, the dead planet feeding on its former host even in death. Then there's the debate tearing astronomy apart. Are these holograms prophecies or memories? The cities bear no resemblance to any known civilization, past or present. Their structures follow mathematical principles not yet discovered on Earth, with curves that approximate fourth-dimensional shapes when analyzed through quantum computing models. But a faction of theorists insists the projections aren't alien at all. They're echoes of a lost human future. They point to fleeting patterns in the light that mirror Neolithic cave paintings, or the way certain buildings transiently rearrange into forms resembling Stonehenge or the pyramids. Could Viga be showing us time out of order, its fractures acting as prisms bending chronology into knots? The most chilling observation came from a solar probe that drifted too close. As it passed through a hologram's outer fringe, its cameras captured something the star's surface never showed: a human figure, clad in what looked like a spacesuit from no known era, standing atop one of the structures. Its visor was cracked. The image lasted 4 frames before dissolving, but not before spectrographs detected an impossible detail. The suit's material matched no known alloy. Its atomic signature aligned perfectly with Viga's crack-lining element. Now the fractures are healing, not quickly, not naturally. The star fights it, its plasma recoiling from the closing gashes like a wound refusing to scar. Every time a fissure narrows, the projections grow more frantic, the cities flickering at double speed as if racing against extinction. One astrophysicist compared it to a dying man clawing at his own chest, desperate to show the world the thing buried inside before the dark takes him. Is Viga a messenger, a mourner, or something far worse, a window accidentally shattered, giving us glimpses of what was never meant to be seen? one truth is inescapable: the light bleeding from those cracks isn't just energy. It's a story, and the star seems hellbent on telling it, no matter the cost. The Clockwork Nebula of PSRB 1257 plus 12 doesn't drifted ticks. Floating in the void where a planet once spun, this eerie structure pulses with mechanical precision, its swirling particles locking into gear-like formations that rotate in flawless synchronicity. Unlike the chaotic dance of ordinary nebulae, every movement here is calculated, rhythmic, as if some unseen hand wound up the cosmos and set it ticking. The first astronomers to observe it assumed their instruments were glitching. No natural phenomenon could explain those perfect, interlocking rings of dust, each one turning like the cog of a celestial watch. Then, in 2039, it chimed. The sound wasn't just heard, it was felt. A deep, resonant tone that vibrated through the hulls of passing ships, rattled asteroid belts light years away, and sent seismic ripples through nearby moons. When converted into audio, the harmonics matched the fabled of Tibetan monks, a frequency said to resonate with the universe itself. But here's what chills researchers: the chime occurs every 12 Earth years to the millisecond. Not 11, not 13, 12. As if whatever engineered this anomaly measured time not in orbits or rotations, but in a unit eerily familiar to us. What could explain such impossible precision? The leading theory points to PSRB 1257 plus 12's violent past. This pulsar once hosted a planetary system, its world slowly shredded by the neutron star's relentless gravity. But one planet designated Polaris Tertius in old star charts didn't just break apart. Scans of the nebula's gears reveal molecular structures aligned like nano-engineered bearings, their atomic lattices arranged to minimize friction. Some physicists argue this suggests artificial origins, a world that might have built megastructures to harness its star's rotation as a power source. When the system collapsed, those mechanisms could have been frozen mid-function, preserved in the nebula's clockwork motion. Then there's the countdown theory. Every 12-year chime isn't just a tone, it's a marker. Spectrographs show the nebula's rotations have been slowing by 0.0001% per cycle, a decay rate that would culminate in total stillness in exactly 960 chimes. That's 11,520 Earth years from now. The date aligns suspiciously with the next predicted galactic core flare, an event that bathes the Milky Way in radiation every 26,000 years. Coincidence, maybe, but why would a nebula count down to it? The most unsettling discovery came from a probe that sampled the nebula's gears. Instead of random cosmic dust, the particles were near-perfect spheres of iron and nickel, each one polished smooth by forces unknown. Under electron microscopes, their surfaces revealed microscopic etchings, spirals, and arcs matching the golden ratio, the same mathematical pattern found in everything from Nautilus shells to spiral galaxies. Even stranger, the particles resonate when exposed to certain frequencies, vibrating in harmony with human brainwaves associated with time perception. Is the Clockwork Nebula a relic of a lost chrono-civilization, a machine built to outlast its creators, or something far older, a cosmic metronome set ticking at the dawn of time, counting toward an appointment we can't yet fathom? One thing's certain: when the next chime comes, the universe will be listening, and somewhere in the dark, the gears keep turning. The hollow core of 55 Cancri doesn't just scream, it pleads. Once celebrated as the diamond planet for its carbon-rich crust, this world's fate took a darker turn when its core collapsed, leaving behind a cavernous void that shouldn't exist. Now the remnants act like a cosmic megaphone, amplifying stray sound waves into shrieks so piercing they've been detected across 3 star systems. But the horror isn't in the volume, it's in the words. The shrieks aren't random noise. They're phrases, fragments of dead languages no human has spoken for millennia, each one a desperate plea for release. The first linguists to analyze the recordings assumed it was pareidolia, the mind grasping for meaning in chaos. Then the patterns repeated. A team at the University of Tokyo isolated 17 distinct phonetic sequences, 5 of which matched verbatim with Sumerian cuneiform tablets describing the beast beneath the mountain. Another sequence, when filtered through Akkadian dialect reconstruction software, produced a chilling imperative: break the chains. The odds of natural acoustics replicating extinct languages. Less than 1 in a quadrillion. What could possibly explain this? 55 Cancri-E's geology holds clues. Before its implosion, scans revealed a labyrinth of caverns stretching deep into its mantle, their walls lined with crystalline structures that vibrated at precise frequencies. Some researchers speculate these weren't natural formations. They were resonators, part of a planetary scale acoustic system designed to trap vibrations. If true, the collapse might have shattered whatever was imprisoned there, allowing its voice to leak through the cracks in reality. The emotional resonance is undeniable. Astronauts who have orbited the remnant report an overwhelming sense of dread when the shrieks peak, as if the sound carries weight beyond decibels. Neurologists confirmed the frequencies trigger amygdala activation, the brain's fear center, at levels typically induced by life-threatening danger. Even stranger, the shrieks intensify during solar eclipses, as if darkness fuels whatever's trapped inside. Then there's the silence. Every 273 days, exactly 55 Cancri-E's original orbital period, the screams cease for precisely 6 hours. During these pauses, seismic probes dropped into the core's outer fissures record something worse. Whispers, not in dead languages, in equations. Mathematical proofs describing gravitational singularities so advanced they redefine quantum physics. One formula, decoded by a team at CERN, outlines a method to fold space-time into recursive loops, a theoretical prison for entities that defy linear existence. Is the core a cage? A research vessel recently risked a close approach, deploying drones to map the hollow interior. The images they sent back showed walls too smooth for natural erosion, etched with symbols matching those found in the ruins of Çatalhöyük, humanity's oldest known temple. The carvings depict faceless figures chained to a black sphere, their mouths open in silent screams. The drones malfunctioned after capturing one final shot, a distortion in the center of the void, warping light like something pressing against the inside of reality itself. Now the screams are getting louder, and the pauses between them, they're growing shorter. Whatever sleeps inside 55 Cancri-E is waking up, and it's learning to speak our language. The painting supernova of SN 1006 doesn't just explode, it creates. When this star detonated over a millennium ago, observers on Earth described it as a guest star shining brighter than Venus, visible even in daylight. But what it left behind wasn't just a scattering of cosmic debris. Its remnants arranged themselves into vast, swirling murals across the nebula, portraits of cities that have never existed, landscapes with geometries that defy earthly logic, and figures frozen in moments of triumph or despair. These aren't random dust formations, they're compositions, and they're evolving. Every year since its discovery, telescopes have captured subtle shifts in the nebula's structure. Last year, the central formation resembled a towering citadel with spires that twisted like double helixes. This year, the same region dissolved into a field of floating obelisks, their surfaces etched with symbols that rearrange when viewed through polarized light. Some researchers swear the patterns mimic Mayan numerals or Indus Valley script, though no direct translations exist. The most unsettling detail, the murals progress in a sequence. When played as a time-lapse, they show civilizations rising from chaos, peaking in elaborate complexity, then crumbling back into abstraction, a cosmic loop of creation and destruction unfolding in real time. What could possibly paint with supernova remnants? The leading astrophysical theory involves magnetohydrodynamic forces, the star's magnetic field, twisted and frozen in place during its death throes, might be sculpting charged particles into these impossible shapes. But critics point out that doesn't explain the narratives. Dust doesn't naturally arrange itself into scenes of crowds gathering beneath arched gateways or lone figures reaching toward eclipsed suns. A rogue team at the European Space Agency recently proposed something radical. SN 1006 didn't just die, it encoded itself. If the star's core contained ultra-dense quantum matter, its collapse could have printed its final energy states onto the surrounding nebula like a cosmic lithograph. Then there's the emotional weight. Astronomers analyzing the murals report uncanny physiological responses, racing heart rates when viewing certain battle scenes, or a surge of dopamine when tracing the curves of what looks like a celestial embrace. The nebula's light carries subtle frequency modulations that align with human brainwave patterns, as if the paintings aren't just seen but felt. During the 2025 solar maximum, when solar winds distorted the nebula's edges, observers described an overwhelming sense of déjà vu, as though they'd glimpsed these scenes in forgotten dreams. The most chilling revelation came from the James Webb Space Telescope's mid-infrared scans. Hidden beneath the visible murals are faint underlayers, older paintings that have been painted over. Some show architectures matching descriptions from Plato's Atlantis. Others depict landscapes eerily similar to Mars' now dry river valleys, but the deepest layer. A perfect, unbroken circle of stars, identical to Earth's night sky 50,000 years ago. Is this supernova a gallery of lost worlds, a prophet painting tomorrow's tragedies in stardust? Or proof that creation and destruction are the same brushstroke to the universe? One thing's certain, SN 1006 isn't just a remnant, it's a storyteller. And every year it adds another page. The last breath of Tabby's star doesn't just dim, it weeps. KIC 8462852, nicknamed Tabby's star, after the astronomer who first documented its bizarre flickering, was already an enigma long before its companion planet vanished. But when that world collapsed inward, the star didn't just mourn, it changed. Now its solar winds carry more than charged particles, they carry ghosts. Spectrographs reveal traces of the lost planet's atmosphere threaded through those winds, molecules of ozone and iron swirling like ashes caught in a sigh. Astronauts stationed on nearby research vessels swear they can taste it, a metallic tang on the tongue, like licking a battery or inhaling the air after a thunderstorm. Some call it the scent of lightning, others insist it's the smell of something older, something wounded. The star's behavior defies every textbook. Normally, stellar winds stream outward in steady torrents, but Tabby's exhales in ragged bursts as if struggling against an unseen weight. During each breath, its light dims precisely 0.7%, the exact amount its luminosity dropped when the planet imploded. Coincidence unlikely. Astrophysicists at the Keck Observatory calculated the odds at 1 in 13 million. The leading theory suggests the implosion fractured something fundamental in the star's magnetic field, twisting it into a feedback loop where every expulsion of wind briefly strangles its own fusion processes. But here's what keeps theorists awake. The winds aren't just ejecting atmosphere, they're ejecting time. radioisotope analysis of the particles reveals anomalies, atoms with half-lives stretched or compressed as if they'd been pulled through a cosmic hourglass. One sample contained iron-56 isotopes that appeared freshly forged, their decay clocks reset to 0. Another held carbon-14 that behaved as if it had already aged 40,000 years. It's as though the star isn't just exhaling debris, but fragments of alternate timelines where the planet never died or died differently. Then there's the rhythm. Tabby's breaths follow a cycle of 11 earthly months, almost but not quite a year. The near-match unsettled chronobiologists enough to cross-reference ancient eclipse records. What they found chills the spine. Babylonian tablets describe a wandering star that pulsed in sync with their harvest calendar. Mayan codices mention a celestial gate that exhaled darkness every 220 days, a number that, when adjusted for orbital drift, aligns terrifyingly close to Tabby's current cycle. But the true horror lies in the silence between breaths. For 17 minutes after each exhalation, the star's corona goes unnaturally still. No flares. No sunspots, just a perfect frozen calm until deep space microphones pick up something else. A vibration, not in the star, in the space around it. A subsonic hum that resonates at the same frequency as human vocal cords during prayer. Is Tabby's star grieving, or is it whispering to something beyond the void? One probe's final transmission hints at an answer. As it plunged into the stellar winds, its sensors detected structures in the particle streams, not random scatter, but patterns. Fractals, and at their center, a single, repeating shape, a spiral. The same spiral found in the last known image of the imploded planet's surface, carved into its polar ice caps. Now the breaths grow stronger, the winds carry more iron, and every telescope trained on Tabby's star reports the same thing. The dimming isn't random anymore. It's spelling something, in Morse, in calculus, in the slow, patient language of something old enough to remember when stars were alive in ways we've forgotten. From whispering voids to laughing pulsars, these 20 imploded planets don't just defy science, they rewrite it. Each anomaly we've explored today isn't just a cosmic oddity. It's a question etched into the fabric of reality. What if planets don't just die? What if they leave behind echoes not just of matter, but of something far more elusive, emotion, memory, perhaps even intention? The gravitational sobs of Cygnus X1, the weeping sculptures of Ceres, the pleading whispers from 55 Cancri-E's hollow core, these aren't random phenomena. They're signatures, footprints in the cosmic sand, left by something that knew it was being watched. But here's the real mystery. Are we witnessing the universe's hidden sentience, or are we the ones breathing meaning into the void? When a pulsar's laughter syncs with human brainwaves, or a nebula's light mirrors our grief, is that proof of a deeper connection, or just the universe's cruelest coincidence? The data refuses to settle the debate. Some scientists argue these anomalies are quantum echoes, vibrations frozen in time. Others whisper about civilizations so advanced they encoded their essence into the stars themselves. And then there are those who dare to ask, what if the cosmos isn't just a place but a living thing, a being so vast its thoughts move at the speed of light, and its emotions ripple through dying worlds like chords through a piano wire? One thing's certain, these imploded planets have shattered our neat, mechanical view of the universe. They've shown us that destruction isn't always an end. Sometimes it's a metamorphosis, a transformation into something we lack the language to describe. The next time you look up at the night sky, remember, those aren't just points of light. They're gravestones, monuments, love letters, and somewhere out there, in the cold between the stars, something might be looking back. Now it's your turn. Do these anomalies hint at cosmic consciousness, or are we alone in a universe that only seems to weep? Drop your theories in the comments, and if you felt that eerie pull while staring into the abyss, hit subscribe. The universe's greatest mysteries are still waiting, and the next one might just call your